Hey fam, y'all, can y'all hear me? Hey, can y'all hear me? For some reason, I can't see myself. Funny enough. Yeah, I'm feeling better. I got more sleep. Pretty much, I think it's the dang. I think his allergies is killing me. Um, hold on. All right, so I'm gonna cover three things tonight. I'm gonna stay super focused. So what I'm gonna do tonight is I'm gonna talk about steganography, encryption, and hashing. So so basically, there's three mathematical things that we always look at all the time, and I'm gonna cover those things. So tonight, this is gonna be off the dome. I'm gonna tell you just like what I think, because I think there's so many times what happens is I think these things are complicated, and so I'm here to uncomplicate things. Does that make sense? So let me go to Excalibur. I'm gonna draw some stuff. All right, three topics again. I'm gonna type them out here. I'm gonna talk about hashing. I'm talking about steganography, and I'm gonna talk about um, cryptography. All right, so I'm gonna talk a little bit about kind of like the history, what you use them for, and all that stuff. Hold on a second here. All right, all right. So it sounds like everybody can hear me fine. So I'm going to talk about each one of these. These are major things because not only, well, this one is not a major thing. To be honest, it's not a major thing to me. Um, yes, these map to Security Plus. Yes, let's we can actually go in here. And the reason why I want to take time to just point these out, these match to Security Plus. Plus, a lot of people have a hard time understanding these things. Let's go to downloads and let's go to Security Plus. So I thought I saw steganography on here. Yeah, it is right here. Yeah. So this is 6. Cool. I'll talk about some of this stuff. The biggest thing I'm going to talk about here to get y'all to understand. Once you understand how PKI works, public key infrastructure, I think that's what it stands for. I think it's going to make everything else way easier. So somebody said 2.2 is also this whole section right here, right? So it's in 2.2 as well. Somebody said. Yeah. All right. Cool. So it's on there too. Um, it didn't talk about cryptography so much. So I knew I wanted to talk about steganography. I must have started 2.2, but what I want to do is talk about both of them at the same time, though. If I go to 6, so we're gonna try to. I'm gonna cover this crypto stuff. This might be pretty cool because I think a lot of y'all, if y'all don't have to wait to the end for this, because sometimes people, this is kind of like some of the harder to understand concepts, but I think the way I explain them, it makes it super easy. Um, so, and there we go. So steganography. Um, so basically, how I explain these, I think I can blow this up too, so y'all can see it better. So hashing is math for integrity checking to me. So some people, so with hashing, it's for integrity checking. So I'm gonna save Stego to last because I think it's like you may come across steganography, and I want to talk about how it works. So cryptography is actually, there's some actually now that I think of steganography, I kind of think of alternate data streams a little bit, and that might be a form of steganography for me. But so cryptography is is, what would I say? It's basically hiding messages, hiding messages in data. Oh, hiding data. Say hiding data, because data is message, right? So somebody, somebody says hashing is a one way. I don't think hashing is one way cryptography. I think to be cryptography, you have to be able to read it. But my job in the military was cryptography, so I was a crypto tech, hiding data, plain text, hiding data, hiding plain text, or some people say clear text. Let's call it data. Hiding clear data with algorithms and keys. That's the simplest way I can describe it. I don't need to say clear because it's assumed clear. So hashing to me is math. It's a one-way operation. It's typically it should be a one-way operation, but I see people using it. People use hashing to verify passwords and stuff, and I guess there are hashes that you could have. So typically it's a one-way. You never would reverse a hash. You can compare a hash, but you don't reverse a hash. I don't know if that makes sense. So that's the difference right there to me. So hiding data with algorithms and keys. Steganography is hiding data in data. I would say probably hiding data in data. That's how we're gonna roll with it. We don't know how to spell that. Is that stenography? Nah, that's not it. So I misspelled so much stuff that I'm always concerned. So those are the three things. And with that, let's start off with a little command line kung fu. I'm gonna open up terminal. And I'm gonna try to make it big. Control Shift plus plus. Alright, that's the biggest I can do. Looks like y'all can see it. Make directory temp. CD temp. I'm just gonna create a directory called temp because I want to do stuff in this directory. Now we can say MD5. Whoops, MD5. Oh, cool. It's already included. SHA-1 some. Alright, cool. It's already included. Looked like you knew what that was. So basically, what the most popular hashing, I would say the most popular hashing algorithm is MD5, right? And that stands for Message Digest 5 or something like that. Don't. I'm like so old. I think sometimes I'm like, man, Marcus, you're getting up there. So MD5 is the most popular hashing algorithm. Famous and widely used, I would say, algorithm. Right? So, now, what this is used for, you take data and you kind of run that data through this MD5 algorithm. Man, we're going to be testing limits of my Texan today because, you know, Texans can't speak well, we can't talk well. So, and so basically this comes out as a string. Now, that string is used to verify integrity of files. So now, like when you download a file, you can prove that file, download, I'm gonna try to make English out of this. Prove downloads are untampered with. However, there's this thing called a collision. There's this thing called a collision that you need to know about. A collision is when two different pieces of data have same. Did I spell collision right? That don't look right. Can I spell? I don't know. That looks better. Am I wrong? Please help me. Thank you. Alright. Untampered. Unchanged. Dang, I'm getting the math worked out or spelling worked out too. God damn, my brain is all over the place. Alright. Collision is when two different pieces have the same summary, right? So sum to me, and like when the command that I just ran is MD5 sum. All right. When two different pieces of information have the same summary, now this is a perceived weakness. A collision is a weakness. Because that means that you can have two pieces of data, and but I tell you what, it's very rare that anything meaningful would have the same MD5 summary. What people have done to create a collision is they take all these supercomputers and they run all this random data through it. It's a technique that if you're familiar with fuzzing, fuzzing means you throw all kind of data at something and trying to get an error. So essentially what researchers did is they got all these supercomputers. Heck, I think it might people be doing stuff like grabbing Xboxes or doing GPUs and all kind of crazy stuff, and they're trying to generate collisions. But those collisions are ridiculous. The collisions are not anything that would pass the smell test per se. So let's just play with MD5 a little bit. So basically, MD5 and SHA-1, SHA-256. The reason why we use those is so we can verify if things are the same. So somebody says you're lagging. Are we lagging out there a lot? Okay. All right, sweet. So I think we're good. All right. So let's go to the command line again. So basically, it looks like I had those commands in place. It's two things you can do at Linux command line to see. SHA-1 is pretty much the same. SHA-256 is just different mathematical operations. But the more, so SHA-1 was hard to do collisions, and then they upped it. 256 is what you can do, and I think I've seen 512, but I see SHA-1. So here's the deal: if you use MD5 and SHA-1 and get a collision with both those, whatever, right? That's kind of like what I'll be thinking. So most things you see online will have an MD5 sum and a SHA-1 sum. At least those, right? So what I'm going to do is I'm going to just create some files here. So I think we said echo Marcus and create test.txt. ls, there it is, cat test.txt. Cool, my name's in there. So now I'm just using the text file here. So I'm using a text file here. Now, so if you do MD5 sum, that's the file. Enter, that's the file. I mean, this is right here is the summary. This is the message digest summary. So now what you do online, actually what I can do real quick is I can say echo carry, and I'm going to do greater than. Now when I do cat text, it says Marcus carry. Cat test, boom. So I created a file by using echo commands, and what those echo commands do is create that file. So now what I do, god dang it, I'm still gonna see it. So we see this says 066. It started with that. Now if I do the same thing with that file, it's 88 done. So this is going to be different for anything that you do. You can get an MD5 sum of executables or anything else like that. So if I said, if I cd to tilde, is this thing right here, tilde/downloads, ls, you see all these files here? So if I said MD5 sum star, I'm pretty sure it's gonna give me an MD5 sum. So the bigger the file, this is math and this is computations. The bigger the file, the longer it takes to process the file. right? So what I'm gonna do is tilde. I'm gonna go back to temp ls. Now if I said copy, that's CP test to test 2. I'm gonna change that to test 2. Do the same thing, star, and they're the same file. All right. The why this is important. Why this is important is because there's a popular piece of software called Tripwire. Heck, there's a lot of software that does this, by the way. Antivirus works like this as well. If you ever looked at Yara rules, Yara or any kind of thing, sticks, and some of these formats to catch bad stuff, one of the things running behind the scenes is these hashing algorithms. So basically, what you can do is there's this thing called a golden image, and you spell it like this. If you're working in an organization, gold build means everything on it, or golden image. So a golden build or gold image, what you would do is you would hash every file on the system. All right. And then what you can do is, if you're doing forensics, you can actually do the reverse, and you could throw away everything that's not hashed, and then you can focus on the things that that you don't know they exist. So gold build would be, you build this out, you can look at the registry, look at everything. You're looking at everything on the machine. That is the gold standard. You know that box is not compromised. And then what you can do is this is how you would tell. So I'm gonna just change. Actually, I'm just gonna say cat butch to test 3. What? My bad, echo. All right. Now you see that that's different. But if I were to create a file with the same, so a collision, by the way, it would be stuff that you couldn't even read. It would be crazy stuff to create a collision. Like right now, if I said cat test 3 or something, or 3, it says Butch. The collision would not be Butch, and probably the collision wouldn't be anything human readable. I mean, to get some kind of collision, it's probably a bunch of garbage that is going to equal that same hash. So to me, I think MD5 is relatively safe. I'm not aware, and somebody can prove me wrong, I'm not aware of any research that has legible, passable data that would matter why it's a bad, or where MD5 would be like totally broken. People say, "Oh, MD5 is broken." I don't think it's really broken. So you see that? It says Mercer gives an example of the data that caused the MD5 collision, and it looks like six MD5 hashes combined together. Useless. All right. So, but there is a stronger algorithm called MD5 sum. So what you would do, by the way, what you can do is cool right here. So you can say this. You can say MD5. MD5. Oh, just say hashes. Oh, I'm gonna say MD5 hashes dot. Now, another thing you can do with this if you're ever confused about this, now watch this. That created something for me. It created this text file. Now, for forensic purposes, and somebody says file integrity checks. So, absolutely. So these hashes are all about integrity checks. So I'm gonna cat MD5. And I have those in here. So if you've been breached and you think that you can use this for two things. You can use this to find bad stuff on other stuff. Like if you know that this is malware, test3 was malware, you could look for that hash on other machines. No matter what the file name was, if it had the same hash, it may be bad stuff. So that's how some antivirus detection engines work. That's how a lot of things work. So remember I told you, Evergreen is how does this thing work? And basically what you have is you got a bunch of programs running these things for us. So if I were Tripwire is a big company still to this day. Tripwire whole money was based on running MD5, point Tripwire to a directory and just do mad MD5 hashes. So just mad MD5 hashes, and what it would do, how Tripwire works, and like a Tripwire as in like the it's like a bomb detonation thing where if you follow a wire it'll blow a bomb or something, right? So basically what the program Tripwire did, and to this day, it just you point Tripwire at a directory, it hashes that directory, and it will continue to do that in a recursive fashion. It's just a loop. Did anything change? And Tripwire will let you know if something changed. So there's got to be open source version of that. So finding bad stuff and identifying good known binaries as well. So if you think something's sketchy, just do MD5 hash on it. And what's cool is that you can probably you can upload these hashes because there's so many rainbow tables out there. You might heard this term called rainbow table. Basically what a rainbow table is that people upload, like they take all these hashes, they take a dictionary essentially, they hash every word in the dictionary, and then what happens, what happens on that is this is crazy, and don't ever do this if you're a coder. Some people have wrote their own code to save passwords. And sometimes they actually just hash the password, like this is a password here, right? And to prove this, watch this. So I'm gonna say echo password. I'm gonna say echo password. Well, actually, my bad. I'm gonna say MD5. Oh no, I'm right. Echo password. And create a file called password.txt. Now, cat, I'm going to say MD5, sum password.txt. Now, some crazy people out there, and this used to be a common practice, what they'll do is they'll just compare, they won't save your password, but they'll save this hash. Now, by the way, this is actually good practice, but you have to actually, you'd have to actually, let me go to my browser, and I'm just going to type in that, I'm going to type in this hash, enter, and watch what comes up. This is going to come up all over the place, and you'll see. You'll see basically that is a common hash. That is just password. It's the hash of password, right? So never use MD5 for authentication. Only use it for integrity. Somebody just mentioned assault. Assault is definitely something that you use, but you wouldn't even use assault with MD5 though, by the way. Yeah. You want to assault the password with a trusted algorithm. All right, so now basically you would never want to do that. As a matter of fact, most MD5, there's probably a table. A rainbow table is a. I remember there used to be DVD fulls of these dang tables, and now since you have all this GPU cracking, people using these high performance gaming graphics cards to crack passwords down. So don't try to do this. That's a wrong move. It's always going to end with pain. All right, so I think the two use cases are Gold Bill. MD5 to me is still okay for that, right? But there's also a SHA-1 summary too. So let's do this. So I'm gonna do a SHA-1 sum, and I want to say SHA-1 sum. I'm gonna do star, and that's all my stuff. I want to say SHA-1 hashes.text. So now I have that, so I can say cat SHA-1, and those are those, and I'm gonna say cat MD. All right, so those are different. You see, there's quite some difference here. Oh, look at that. SHA has all this stuff. So let's do SHA-250 512 star. God dang. That's a whole heap, and look how long that joke is right there. So the odds, and the reason why you have these different ones is that for each time, every one is harder to make a collision. So the integrity of these files are better and better and better. And so this is not to me, and you know, you may find something else, you may find it somewhere else. I don't like to talk about hashing and cryptography in the same sentence, because people will do this. I guarantee you this right here. This is password.txt. The contents of password.txt is we know what it is. I'm going to do the same operation. I'm going to copy this. I'm going to copy that. And then I'm going to go to Google and just type that into the browser. Boom. It came up. So I can guarantee you that if I click on one of these things, so what it says, cryptographic hash functions. I mean, to me, when I talk about crypto and cryptography, I'm not talking about Bitcoin, and I'm not talking about hashes. But maybe I'm just crazy. The problem with calling it cryptography is that there's people out there that think that they can hide passwords and that stuff, and it's only a one-way situation to me, right? It's one way. It's only used for integrity. So like hashes are only used for integrity. Hopefully that makes sense. Hopefully I didn't beat a dead horse. But these things are good. These things are certainly good for getting integrity done. So I'm gonna take a break real quick, and I'll be right back. I think Bambi just came in the room. Hey, just so we're on the same page, fam. I'm gonna be back at a quarter till. That's 5 minutes from now. All right, fam, can you hear me? Wow, funny enough. Wow, Edge. Hey man, Microsoft's killing it. Microsoft's killing the open source game. I can't believe I'm saying that, but they are. So what I want Microsoft to come with a Linux system. I think they would do it well. So, and I think they could put some Microsoft services on there. It would be freaking amazing. So, all right. So what? So I think we covered hashes pretty dang well. Um, I think I'm gonna just sum it up. MD5 is still good for me for integrity checking. You should use bigger algorithms as you can, but if you have old tools that support MD5 only, it's better than nothing. All right, so next thing I want to talk about is I'll talk about cryptography. I'm gonna have to do a little bit of setup for steganography, but cryptography. Let's talk about that a little bit. So cryptography is two things. This is coming from my perspective. So cryptography is two things. Hold on a second. Let me try to get some more space. A little bit. I just walked outside real quick. My wife's out there gardening, and it's not good for my allergies. All right, so let me go down here. Let's talk about cryptography. I'm going to zoom in. All right, cryptography. This thing seems to slide up. So basically, with cryptography, you have to have two things. You got to have an algorithm plus some kind of key. Now, you can have a crappy algorithm. You don't have to have a really good algorithm, right? But there's turbo algorithms. A key can be something you know. So there's simple substitution ciphers where the algorithm is substitution and the key is the map showing you the maps. There's two major kind of encryptions that we would call this. So basically there's two kind of different ones: asymmetric or symmetric. I'm gonna misspell some stuff. Alright. And I think the other one's easy. Now this is super important. So basically, symmetric encryption means that we have the same key on both sides. Right? Asymmetric means there's a different key on each side. And usually that being a private key and a public key. Now, by the way, this stuff I'm telling you right now is so funny, is because I talk to people all the time that are real technical, and this is confusing as a mug to people. Super confusing. And the truth is, most communications is a combination of these, right? So the good thing about, so there's pros and cons. So the pros is this is faster. This is faster because both sides have the same key. It is not as memory intensive in some cases. But the con has always been cons is key distribution. All right, key distribution being, how do we get the same key? When I was in the military, they used to have we used to have basically we used to have key tapes back in the Navy, and basically you example how this would work is you had a different piece of crypto for every day. So say if you had 30 days worth of crypto, if we did have 30 days worth of crypto, we would be out of crypto in 30 days. So what they would have to do is they would have to give you crypto way in advance back in the day before you went on a tour. So we were going on a 6-month deployment. You needed you needed probably at least 6 months worth of key tape, right? There's actually electric distribution now, electronic distribution. But most of the time, you're gonna have to have some kind of key in the beginning. Well, that's actually just a piece of that. But let's just start there. I'm gonna try to do some indentation here. So there is electron distribution, but it's still a pain. If you lose some kind of medium, or if you lose something, you're screwed. Basically, what the thing that happened to make asymmetric crypto is really cool because there's with this there's all kind of, so basically it allows you, and there's some algorithms and stuff that we can talk about. I think the algorithm, the key algorithm that a lot of people thought, there's a couple of them, but let me make sure I got this right. So basically, Diffie-Hellman is the one that most people talk about. So you can read a little bit about this, and there's videos on it too. It looked like a Khan Academy video. So go check that out. I'm gonna give you the Marcus Ghetto version of this. So basically, without knowing each other, we can exchange keys. We can, without knowing each other, we can create a session key, is what I would say. So basically, I don't know you don't know me, but we can come up with this. We can create a session key that's secure and nobody except us know. And there's just like this whole protocol, this handshaking protocol that you can do. Computer file video on Diffie-Hellman is great. So another form of this is people talk about public key. I think it's PCAP stands for infrastructure, I think. But what's important about this is that you have a public and private key. So the public and private key is pretty cool. So what you do with the public key, each person has 2 keys. Now I'm gonna do a diagram with this because this right here is super confusing. This is confusing to a lot of smart people. I have discussions with real smart people all the time that don't get this. So I'm gonna draw this out. So basically, every person I'm going to use somebody as an example here. All right, before I start this, how many people have a problem understanding this? Just so I think it's a problem because I talk to people that are like really technical and they don't get it. or they can't explain it. This is Marcus. Who gets it? It's a tough. Boom, boom, boom. This is Wobbuffet. So when we first start off, we have two keys. we both create our keys. I'm gonna create a public key and a private key. Let me try to zoom in on this. Now, there's a lot of different implementations of this, but it's all the same. Remember how I like to think? I like to think, how do we break this down? How do we break this down? And so this what we're doing here is we're breaking this down so it's what I call evergreen. So I'm gonna give you the evergreen version of this. So there's basically what we do is there's some third party that we both trust. You can do this totally untrusted, or you can do it trusted. Right? So what we do here, we create these two keys are forever connected with each other. All right, so that's that key. And this works for all, like most encryption that you talk about. This conversation here works for it all. So hopefully this is an aha moment for some of y'all if y'all don't get it. This is super. This is like I said. This is some super evergreen type stuff right here. All right, boom. So what's cool about this? These two keys are not the same, but what they do is the private key can send something to the private key can encrypt the message, and the public key can read that message plain text. And it goes back and forth. A public key can create a message, and the private key can understand it. The difference, the main difference between the public and private key is the private key I would never share with anybody. But the public key, what I would do with the public key is I would send this out here. And this is Marcus. This is Marcus public key. And we go over here. And we're going to grab Wobbuffet's public key. So, there's a couple different names. There's a couple different names for these people. But I'm just going to say it's a trusted third party. The same kind of thing, if you ever heard of a certificate authority, there's all kind of different names for this third party right here. You used to be able to publish these on, you still can. People would upload them to websites. So now, if I wanted to encrypt a message to Wobbuffet, I would say, hey, what's Wobbuffet's public key? I would take that public key and I would pretty much download that public key. And I would say, oh, if I want to talk to Wobbuffet, this is public key. And he want to talk to me. Well, dang it. If he want to talk to me, he can use my public key too. So once he takes a message, that message is hi. That hi is going to be encrypted. And that hi is 2 letters. I'm just going to be goofy here. So say if that's X W for whatever reason. That's encrypted. So what's cool about this is he would send this, he would want to send it to me, he would encrypt it with my public key. The message would go to me, and I decrypt it with my private key. And now when I get that, when I decrypt it with my private key, I know that said hi. But once Wobbuffet encrypts it, Wobbuffet can't even decrypt it, and he doesn't know what it is. Right? So now if I want to, so the same operation happens. I want to talk to Wobbuffet. I'm going to take his public key or their public key. Hi, and it's going to come over here and encrypt it, and Wobbuffet's going to be able to decrypt it with Wobbuffet's private key. So that's and also digital signatures work the same way. So if I sign something that says MJC. So what's cool about digital, if I say I'm going to send a message to Wobbuffet, so I'm going to use 2 pieces of crypto. I'm going to take my signature and my signature MJC, and I'm going to encrypt it with my private key. So that digital signature is going to come out as something else. HEK. So say this is my encrypted signature, but I'm encrypting it with my private key. When Wobbuffet gets the message, I'm going to encrypt it in his public. I'm going to encrypt it in Wobbuffet's public key using this, and it's going to be an encrypted message. Now I understand why this is hard. People don't understand it because it's kind of hard to explain. So the encrypted message is going to have my digital signature inside that digital message. This is MJC. This is the encrypted message. It's all encrypted in Wobbuffet's public key. You dig? So that message is going to go over to Wobbuffet. Wobbuffet is going to unencrypt it, the first piece, with the private key, because this is going to be encrypted with Wobbuffet's public key. Encrypts it, and then Wobbuffet sees a digital signature. Wobbuffet knows that this is a digital signature, right? You don't have to create a new pair. You can expire certificates, but oh my bad. If your private key is compromised, you just revoke the old one and you create another one. So since I encrypted my signature, digital signature, with my private key, what Wobbuffet will do is it'll go look in my public key. It'll use my public key right here to decrypt this message. Whoops. Now technically, the only person in the world that should be able to decrypt this message is me. I mean, is the only signature, the only key in the world that can decrypt my private message, encrypted with my private one, is my public one. So it works both ways. So now Wobbuffet can prove that, well, the only person that could have signed this with a private key that I can unencrypt with Marcus's public key is Marcus's private key. So this message must have came from him. Right? Does that make sense? This is complicated. But like when you go to a website, it works like this, by the way. So the private key is held privately by a web server. It's held privately by me as a user. If I wanna send private email to somebody, I would look up your okay, what's their key? Alright, cool. I need to encrypt my message with that key, and also I'm gonna sign it to prove that I'm me. I'm gonna sign it with my private key. You look at my public key, it works both ways, and it's amazing. It's pretty dang slick on how that works. So every time somebody talks about private key, public key, and asymmetric encryption, most of the time they're talking about this. Now with web servers, there's this thing everybody uses now called Let's Encrypt. And you can get free SSL search now. So this is, and all these major sponsors behind this. This is a great 200 million certificates. So basically, this is how this all works. So Dave Curtin said, asymmetric is stronger, but slower. Symmetric is faster. Haha, that's true. But check this out. So asymmetric is good because now I can publish something that anybody can look up my key and they can send me a private message. But it's actually harder to do, right? It's harder to do. We usually use symmetric to secure exchange. Yep. So Alpha Whiskey. Alpha Whiskey is on it as usual. Shout out to Alpha Whiskey. So basically, what happens is this right here is very expensive to do. So if we wanted to have like a phone call, if you want to hit somebody on Signal, everybody got Signal, pretty much. If you don't have Signal, Signal is what a lot of security people use for encrypted communications. Signal is an app on iPhone and all that. So what you do is this. You do asymmetric encryption you exchange a key, right? Now the SSL cert is used as a proof of who I am. Hey, look, I'm really Facebook, I'm really Google, whatever. But we'll do this Diffie-Hellman type exchange to exchange what we call a session key. So this stuff is all working together. So, hey, are you really Cisco site? Cisco signs something with their private key and I go to the certificate authority, and I'm like, oh yeah, that's Cisco because they signed this little bit of data. That must be Cisco. We're gonna start communicating, and then what we're gonna do is we're gonna actually create another key. Once we kind of, I validated your Cisco, I validated that, and that's all asymmetric. But like I said, it's hard because you're encrypting something with a key, that person encrypting with another key. You're encrypting this with a key, that you gotta look this up, all this other crap, right? So what you do is you create this thing, I'm gonna say SK, and now what you're doing on here is you're talking directly to them. This is called a session key. So you use asymmetric cryptography to begin the conversation, but as soon as you can, whoa, my bad. I'm talking behind. Pardon me. Somebody just mentioned that they couldn't see it. So what you do is you use asymmetric. That was funny. Asymmetric. Use asymmetric to exchange a session key. So basically, you both use asymmetric encryption, and then we're going to exchange the session key because now we're talking the same key. It's less expensive for memory and all that stuff. So now you're talking on the same key. Hopefully that makes sense. So asymmetric to get to a session key. Now what that does is that actually gives you the ability, like I said at the beginning here, I probably said most is a combination somewhere. So basically, you use asymmetric cryptography so you can start having a private discussion. Then you can create a session key to talk. Now you're going to be able to find. I spelled that wrong. Such a dork. That's one way to spell it. All right. So that's how that works. Asymmetric encryption is cryptography, no matter how it is. It doesn't matter if it's websites, if it's phones, cable, wherever crypto is involved. It's probably like in software ships with public keys all the time. And the private key is held by the software provider and things of that nature. So that's how that works. So any quick questions, my family? What y'all got on this? So anytime you hear about this stuff, because when you start reading algorithms and stuff, it starts getting crazy. It was that way for me too. I just like to break everything down real simple. I'm just a country boy, so I gotta break the stuff down. I'm good for now. Learning about the ASCII. That's ASCII. ASCII. All right. So here we go. So that's two things down, and now we're gonna get into steganography real quick. So I explain these things on a super high level, and the intent is, so I want to break this stuff down so it's easy for consumption, and then you'll go on to look at other resources. There's a tons of good resources out there that like do deep dives into all this stuff. But remember the core principles, and you're going to be fine. All right, so let's go to this dang steganography. Steganography is hiding data in data. Sometimes people think of steganography and think of hiding things in plain sight. I've seen all kind of different examples. I want to do a quick Google search for a steganography example, and because I'm probably going to get the typical thing that I see. All right, this is the kind of example that you'll see. And this is a word, but this is an example. This is just a picture of it. So all the things that I see are trying to do this kind of stuff. But the real steganography, you see right here, it's talking about bits and bytes. Hopefully, I can get a hex editor down. Let me try to download it. I gotta get a hex editor, real quick. Let me try to get one. It's gonna require a little prep. Bear with me. Anybody got a good hex editor they recommend I download? Anything from Linux y'all like? All right, so So I'm gonna type in hex editor. Ghex. I've used this before. Alright, so basically what a hex editor is it lets you... is that an online hex editor? God dang. Charles Cabbage is coming through with the stuff, with good... So I'm gonna launch this text editor. Hex editor, should I say. Wow, what's that? Is this thing on? This thing work? God dang, it didn't work. Does this work? Golly, man, this sucks. Alright, you know what? I'm gonna go to old reliable. Alright, let me see real quick. Alright, so what I'm gonna do here is I'm gonna try eventually do a back capture. I'll show you. I think I can probably show you something cool. Hold on a second here. I think I can show you something pretty dope. Alright, so hopefully Wireshark opens. I tried to dang. Hold on, be patient with me, family. I need to get a hex editor to work. I think I tried to get Wireshark to work, it didn't work either. Alright, so I can type in frame contains JPEG is JFIF. Alright, so there's a couple things I can introduce y'all to. So if you might not know, you might know. I'm gonna look for file signatures. And I think I know what site's gonna pop up. But if you look for file signatures, this one right here, Gary Kessler, GaryKessler.net. I went fast there. File signatures, Gary Kessler is the one you wanna go to. So what's really interesting about this is in a hex editor, and please Lord, let me get a hex editor working during the session. There's different headers on the files, and these are binary headers, or this is hex, right? But if you look in here, those are the things. So you remember how in Wireshark, I'm gonna try to blow this up real quick. Make this huge. So a file represented on a computer, and that's binary, but this is hex. So that 54 equals T. That 52 equals R. 55 equals U. So every file, pretty much every file has some kind of format that's represented on a digital in a digital way. This right here, it says MPEG 4. So if you have a sniffer and you were looking for MPEG, if you were looking to see if anybody was streaming content, you can look for that, right? It says trailer though, by the way. But if you're just looking for this representation, you can build a signature for that. You can build a signature for that in Snort or something. And we're looking through all these. Microsoft Money. My son is gaming right now. I think he's playing Siege or something, and he's making weird sounds. He's nuts. PPT, you see this right here? Subheader for PowerPoint. All these different things have different stuff. Launch, can I open it? Oh my goodness. Why can't I run any programs? Dang it, there's a dang binary one I could use, but I haven't used it in so long I forgot how to do it. Oh my gosh. Well, this is crazy. So it looks like I can't execute any files. Marcus is not happy. I, oh, that's not it. Dang it. There was a dang hex. There was a hex thing. I can't get a dang. Somebody said hex. Is it hexdump.it? Hex.it? Let me go there. Oh snap! We got 15 versions of the joke open up. And dang, it took forever. Alright, so I'm gonna just open up a file I got locally here. I'm gonna go down here to my downloads and let's open up a PDF file. PDF is gonna have a signature. So in here, can I zoom in this? Let me see. View, zoom in. Alright, I can zoom in, hold on a second. Alright, so this is a hexadecimal representation. You see this right here? It says PDF. So this percent PDF, that's the header for a PDF file. So if you're sniffing traffic in plain text, this PDF thing is probably, that looks like the signature for that. So what we can do here is we can go over to here, and I'm just going to search for PDF. Oh, look at that. Percent PDF. See that? So I got a virtual machine, man. I need to allocate some more memory to the VM. So it's hurting. It's a hurting puppy right now. All right, so when you open up a file in a PDF reader, it's gonna show you that file. When you open up a raw file, and this is like getting down to the nitty gritty here. You see, this is the beginning of this file, and then it's showing you all the way down to the end. So every little byte on this computer is represented here. I mean, on this file. So this is a PDF. If you wanted to write, and this is handy because like maybe there's a file format that a hacker is using, and you can maybe spot those files by some kind of signature. Matter of fact, real talk, this is how Yara works. YARA. You can actually put signatures for binary files and stuff in there. So, why is this important? This is important because you have to understand how file formats work if you want to understand how like real steganography type stuff works. So what you see this percent in the file, that means it's the end of the file. So typically what steganography does is it actually will add data at the end of these files. I can insert random data or whatever in here. So you can actually take this PDF file and stuff it with data. Now, what I'm going to do here, I want to stuff with random data. I'm going to insert that. Hopefully, I don't know if that's going to even work. So that's the end of the file. Alright, so I did add some random data there. I'm going to save this file. And what's interesting about this, I don't know if this is going to destroy that file, because it could totally destroy that file. It could render that file unusable, put it like that. I just put random data in it, but what I'm going to do is I'm going to go see if I open up that file. And that was a snort file. What's interesting, you can still see I can still see the shortcut here. So it tells me that PDF, it tells me something is reading this as a PDF, not just a PDF file, is representing it that way. A corrupt file sometimes won't have a little thing on it. Alright, so boom, here's that same file. But in this file, and I inserted random data. I don't see any data in here. I don't see anything. I went to the end of the file and I inserted random data. Now I could scan through this file or whatever, but I don't see that file here. I don't see it here. So this is what's important, right? Attackers can put data in any file and use that for some other purpose. They can also steal data by doing that. So you can take a bunch of files like this PDF that I just did, insert data in it. You could take it with JPEGs or any kind of other file format. Just understanding the file formats is why it took you there. But this is done with images a lot. I don't see the data there. And so that was random data. And in some cases, because of the file format of the PDF, it may not show. And that's always the best kind of data. So typically when you think of steganography, most people think of it as some kind of image. But the fact is, I could take any file and put data in it, and as an attacker, I know where the data is at. Right? Yes, you would absolutely be able to see the file. And so you don't have to see the data in plain sight, by the way. Don't, if you did, then I've been. So this right here, what I'm telling you, this is how steganography works in modern attacks. Absolutely. Usually it's in something that you can't see. You would never see this data. You're stuffing data at the end of stuff, and the data, from a programmatic standpoint, you would run a program to pull the data out. So hopefully that makes sense. So that's how, when you think of steganography, think of an attacker using it in that way. Not images. It could be an image, but it could be any freaking file you want. It could be any file, because files are made up of this stuff. And if I can slip it in there, because I've tried to edit these things. Funny enough, you see this? There may be multiple end of file markers in the file. When carving, make sure you get the last one. So this is actually a pretty good resource. I've used this resource a lot to understand files and things of that nature. So basically, there's actually tools you can download to play with that will hide the data. You'll take a file, you take a message, and what it'll do is it'll automatically put it in there, right? So it'll take the file that you say, and you can. I'll download it so you can be safe. I can do this on this box. I don't want to waste your time doing it now. It takes an image and it'll stuff it with data on it, right? And then you run the reversing algorithm will pull the data out the data. So you're not going to physically see the data. Maybe there's parlor tricks that I've seen where it'll hide it in the pixels, but that's just stupid though. You don't need to hide it in pixels. You know what I'm saying? Like if it's a website, oh, there's a secret message over here on the left. Nah, you're not doing that. You would take this whole banner image and you would stuff that banner image with data that you don't see. So, how do you hide it? But how do you execute it? Yeah. So basically, these files. If I said, let me go to download, let me go to downloads, and if I said cat this, or if I said the data is still there, I don't know how this is going to render this, but what was that, snort? So that data potentially is somewhere down here. If I wrote a program, what I would be able to do is I could set offsets for this to grab this piece of data. I could write a program to say, hey, right before EOF is my message. Right? And that's how you do it. What the heck happened there? Oh, so that's actually funny enough. I think that came out automatically. You see all that crap that's shooting out there? That came up because I catted that. That was like random stuff came out. So yeah, but this file, as you saw that. Probably at the beginning we'll see a % PDF. So even though you can't see it, it is what it is. It's a binary file. I don't know. It went over the buffer, so I can't scroll up. But yeah, that's how you would do it. You write a program to just grab it. Now that could be all kind of. It could be useful information. It could be a configuration. It could be like an IP address of a server. It could be of something that they're using. So when you go in, it doesn't look like a regular configuration file. It could look like a Microsoft logo or something like that. You feel me? He's saying being used by some as malware. So yeah, I mean, so it's basically instead of doing it obvious, what you do is you just drop a file in there. It could be like I said, it could be a Windows logo. It looks like it totally belongs there, but the program will go in there and grab the data that it needs to do its operation, and that's how an attacker will use it. That makes sense? Because it's easy to, like, if an attacker could write a JSON file or a YAML file or something like that, but just for obfuscation purposes, if you just drop the image in a folder and it's just sitting there, you're like, oh, what's that image? But if it's like something, I mean, they could take your company logo and they could put data in it. You know what I'm saying? All right, so, my eyes are tired. I'm about done for the night. Hopefully, I covered those subjects. A Facebook meme. Facebook actually changes those things. I would test it out though. That would be interesting. A Facebook meme, can you stuff data into a Facebook meme? So what happens most of the time when you upload to most sites, they change the image now. They change the metadata, they're changing stuff about it, and they're creating a new file. So it would probably be, I would, it's a good test though. If I were you, that would be a nice test. Try to use try to find a Stego program. Try to hide a message in it, upload it to Facebook, download it. That'd be good research. That'd be a great blog post, by the way. That would be great. it would be a really good blog project. See if you can hide steganography on. And there's probably somebody already did some research. But hey, there's nothing wrong with you going out there and playing around with it. But that would be something interesting to me. So, hey, I appreciate y'all. Thanks for showing up. I will see y'all Tuesday. I expect to be operating 100% capacity Tuesday. And hopefully, yeah, I appreciate that. So, remember what I do is I want you to think how this stuff basically works. And then you can add all the technical mumbo jumbo on top of it. Like I said, I'm a country boy. We like to keep it real country and simple in the country. You know what I mean? So, all my Texans out there, y'all can understand what I'm talking about. All right, y'all take care. Have a great one. I will talk to y'all. Hey, finish out that section. Take notes on the crypto section. I covered that tonight. Take notes on it, and I will talk to y'all next week. Bye-bye.